Good evening, children. Hope all good. So today's class will be in reflection coordinate geometry for standard 10. Now, the reflection which you have heard about is same that you learnt in physics, right? So we have, in maths, we have two kinds of mirrors. One is point mirror and one is line mirror. Point mirror is, the mirror is just a small point. That's termed as reflection in a point. Like you say, reflection in origin. So the mirror is reduced to a point. So in that, only the object distance is equal to image distance, and the object image and the point mirror line one straight line, as I've shown here. So this is the point, which is a mirror. So in the form of a point, this is object point, point object. Okay, A is a point object. So what is the rule for reflection of a point in a mirror which is also a point? So you just have to join A and P, produce that straight line through P such that AP equals PA dash, where A dash is the image of A. So we are just doing object distance is equal to image distance. Object distance is distance from the object to the point mirror, and image distance is the distance of the image from the point mirror. That's all. That is the rule here. The other one is line reflection. You can see the arrow. So a mirror has no end points. It's not a line segment. It's just a line. Like the mirror at home, it just has a fixed boundary. So if you go beyond the boundary to a certain, beyond the view of field, you'll not be able to see your image. But in maths, the mirror can be extended on either side. Okay? So it's not a line segment, number one. So the mirror, you should show arrows. Then this is point image, this is the point object, and this is the image. What are the two rules you must remember? Same as that in physics. Only in physics, you have a front of the mirror and the back of the mirror. The polished part is the front and the darkened part is the back of the opposite side is the back of the mirror. In maths, there's no back and front of the mirror line. The object can be on either side of the line. If the object is here, the image is on the opposite side. If the object point is here, the image is on the opposite side. That's one difference. But the rule of reflection in a line is very important. And that's what we don't start reflection straight away, reflection x-axis, reflection y-axis, reflection origin, and we have a formula and children by heart the formula. But what is the meaning of this reflection? Same rules as it goes in physics. The object distance Pn should be equal to image distance. An object distance, now it's a line, so it has to be perpendicular to the line. The shortest distance between a point and a line is the length of the perpendicular dropped on the line. If I want to know what is the distance of P from the mirror, it is, you have to drop a perpendicular, not any distance. This is not distance from mirror. It is only the shortest distance, which is the perpendicular distance from P to the mirror, and in the figure it is Pn. So first thing what you do when you do reflection in maths, whichever point is given, you drop a perpendicular first on the line which is to be the mirror, the line in which the point has to be reflected. First step. So first we drop a perpendicular, and then this distance is equal to this distance. So Pn should be equal to P dash n, and P dash must be perpendicular to L1, L2. L1, L2 is, say, the mirror line. I cannot name the mirror because it has no ends. But just to say line, just to show you that L1, L2 is on the mirror. Because when I put names L1, L2, it becomes end points. I'm not talking of end point, just I'm representing that along L1, L2 is the mirror line. Is it clear? So therefore, these are the two things, if you remember, any kind of sum you can do. So basically, what are we doing? We are doing reflection of a point. With the point location, we are taking coordinates. So pair of coordinates. You have done coordinate geometry. Generally, we do this chapter after coordinate geometry. We do so. You have a concept of what are coordinates. What's the meaning of x comma y? When P is located at x comma y, you should know what is x and y. X is abscissa, y is ordinate. So x is the distance from the y-axis, y is the distance from x-axis. X is called abscissa, y is called ordinate. Okay, that means I'm showing here. This is x-axis, this is y-axis. So when I'm talking of a point xy, it's a point. Xy is the location of a point with respect to two lines of references called x-axis and y-axis. So this distance is x, and this is, so for you to remember, horizontal distance is x, vertical distance is y of a point. From where? From the two lines, that is y-axis and x-axis. So x is distance from y-axis. X is not distance from x-axis. Y is distance from y. No. Why someone didn't invent that, I don't know. Right? But x is horizontal distance, y is vertical distance. X is called abscissa, y is called ordinate. So I don't want to go into details of quadrant geometry now, just a revision, because we are dealing with reflection of a point. Okay? It can be, this reflection can be done, reflection of geometrical figures, and which is very much similar to line symmetries. It can be done reflection of coordinates, points given in coordinate form. So this reflection can be done graphically and formula wise and construction. So all three ways. Okay, by graphically, even if you don't know, if you know the rule how to drop a perpendicular from a point to a line and then measure the object distance with the compass and mark on the other side on the perpendicular the image distance, that's all, that's the image. So you can, so I'm writing it down here. So first thing is a reflection. The mirror is a form of point. This is only the rule. Object distance equal to image distance. You just have to join AP. A is the object point, P is the mirror point, and extend it so that these two distances are equal. This is point reflection, right? Reflection and origin is that. So I'm going to come to that because origin is a point. There you have line reflection where mirror is a line. So object and image are on the opposite side of the line. They are on one straight line which should be perpendicular to the mirror. So the mirror should be the perpendicular bisector of PP dash. Okay. So what we are going to see here. So we have done point reflection. I'm rubbing this. So line reflection, let me do a little bit. What are the rules? So you have PP dash must be perpendicular to L1, L2. That means the line joining the object point and the image point, that straight line must be perpendicular to the mirror line. That's the first thing. So when I give you a line reflection and I ask you reflect this X in this line, okay, the first thing, now I am doing say by construction. Nothing is given, no coordinates. So it's not that only in coordinate geometry we have reflection. We can reflect anything in the mirror. You see anything in the mirror. Does the dog does not see its image? Does the point does not see everything? But in mathematics, what we do deal with geometrical figures and points. Okay. So therefore, we are only reflecting geometrical figures in a line, or we are reflecting points in a line. Right. So first thing, you drop a perpendicular. Suppose you have Lubecker, you can extend the line. You have the freedom to extend mirror line till the end of your book, no problem. So suppose you do, nothing is given. Just they say, now if a small child is going to draw a reflection, he'll just draw looking like this and he'll put it like that. But suppose you, okay, an older student, 9th and 10th student, you take a compass and you know how to drop a perpendicular, take the compass, put the point, center pointer, at the center of the circle, you go to cut a curve, take the arc length more than this distance and just cut an arc from this point. Dropping a perpendicular from a point to a line. And then from here, okay, you got the arc of the compass, from here you cut like this and from here you cut like this. So this is a revision of, so it looks crooked. So this is a revision of, so I think it will be good. So it will come like this. So then you have like this. So you can see this is dropping a perpendicular from the point X on the mirror. That's all. That's number one. That's the first step. And if it's just a rough sketch, construction word means you have to do construct, use compass, ruler and all that. If I say draw means just freehand drawing, that doesn't mean any crooked line. Use a ruler, use a pencil and do it. Not to scale, not to with compass and all. Just the rule. So you drop a perpendicular and then measure this distance, whatever it is, cut the arc here. So this becomes X dash is the image. So always remember, so the other thing in the rule is, so which one I'm talking about? That is the rule to find the image. So let us refer to this. Number one is that. Number two, Pn should be equal to P dash N. So how to? By construction, how to get the image of a point. If the image is here, object is here, image will be here. So either way we can reflect in maths. Mathematical reflection, the object can be, a point object can be on either side of the mirror. Okay. Remember always the image will be on the opposite side of the line mirror. So here, next is object. You have done in physics, U equals V and you call U as the distance of the point object. You always, even if an extended stick you make in a physics, okay, you take this image and this image. By ray diagram you do. You draw two rays, one perpendicular which goes up straight, another one this, and then where the reflected rays meet, you will see it will come on the perpendicular line and object distance will be equal to image distance. By ray diagram you do. Here you are doing by the concept of reflection, object distance should be equal to image distance number one. It's not that I draw, again I'll show you this is the object, so it's not this and this, so therefore it's the image. No, because this is a line, mirror is a line, so it has to be vertically opposite. So when you're looking at the mirror and you're trying to apply makeup, do you look slantly at a slant angle in the mirror? You look straight, right? You don't look like this and apply the, you don't look at crooked. Your image is exactly opposite to you. So diagonally opposite to you, not diagonally, vertically exact opposite to you. Vertically opposite, just straight line. So therefore that's the rule. That's all. If you remember these two rules, you can do reflection. So what I said, reflections can be done by construction, okay, then by graphical representation, graphs, that is generally for coordinate geometry. When you are given coordinates, point is a coordinate form. Because if you are using graphs, you are taking x-axis, y-axis means you are taking the locational point by distances of measuring its distance from y-axis and x-axis, that is x comma y respectively. Third one is construction, graphical method, and that is construction and graphical method. Okay, so either you are doing both methods or formula. Third is formula. Like teacher teaches you reflection of point x, y. Coordinate geometry, formulas for coordinate geometry, not for rectilinear figures reflection in a line. Okay, so here your formula is for reflection of x comma y in x-axis is x comma minus y. In y-axis it is x minus x comma y. In origin it is of xy, it is minus x. That's how teacher teaches you the formula. But do you know what is the meaning of reflection? This is the meaning. Same meaning. Reflection in physics and reflection maths is not. The only difference is I have object on either side of the line. Okay. So here these are the three parts. So let us take, for example, I'll give you this. I showed you a point, rule for point reflection, okay, in a mirror line. Okay, so here, suppose you are doing like, let's go to coordinate geometry, graphical method, right? Graphical method. So you know these rules. I'm rubbing it out. You can just see your video. If you have doubts, go back to it and just listen. Okay, I'm going slowly. Okay, so here, keeping this there, now you see, I'll make x-axis, y-axis closer to me, right? So here, suppose this is the x, the y-axis, x-axis. This is the negative, this is y negative, this is y positive, this is x negative. Origin. So you take in your graph paper, you have 2 centimeter graph, that means every 10 divisions 2 millimeters. So therefore you have every 10 divisions 2 centimeters. I'm taking 5 by every 1 centimeter is 1 unit. Every 1 centimeter is 1 unit. You have many kinds of graph paper. So I'm just saying 1 centimeter is 1 unit. This side is negative. Same distances because each unit differs by 1. So the distance should be also same. Right? Here also negative y. You know coordinate geometry. 10th standard this is, children. So you should be knowing, and you have done coordinates in graphical representation of linear graphs, simultaneous graphs. Okay? So drawing two equations, linear equations on a graph, or a single linear equation on a graph. So here, and this is 1, 2, 3, 4, 5. Now what is reflection in x-axis? Let us take a point. Okay, so you know that xy is positive here of a point. Here abscissa is negative, another point. Here it is minus x minus y, both are, and in fourth quadrant point C will be x minus y. So you know that. Okay? So the both negative here, both positive here, abscissa negative, y positive, x negative, y positive, x positive, y negative. So straight away when I say minus 2, 3, where does it lie? Here. Where does minus 1, minus 6 lie? Here. Where is 5, 4 lie? Both positive here. Where does 6, minus 2 lie? So you should not plot the point different. Okay. So now when I say reflect a point xy, okay, in x-axis. So let us take one known point first, then we'll derive the formula. Suppose I take point 4, 2. This is 4, this is 2, so I write, sorry. This is 4, this distance is 2, so this is 2, 4. Horizontal distance of, we name this point as P. So in the graph you will locate two units from the y-axis, 2 squares of 1 centimeter each from y-axis, and 4 squares of 1 centimeter each from x-axis. That is the location of P. Reflect this point in y-axis. Now the whole y-axis is the mirror. What did I say? First drop a perpendicular. So take a scale straight. You have a straight line. It's a graph paper. It's a plain board for me. It's a graph paper. So go straight out. And you don't have to measure with pencil, with a ruler here. Okay, that is when you are given a line and no graph paper. Then you measure this and then you go that distance. Right? So object distance is equal to image distance. So here I go straight. Then you know already it is 2 units. So I go 2 units here. Behind the mirror. In front of the mirror it's 2 units back. So here it comes. The point comes here. So this is the image, P dash. And what it will be? This remains 4. But this becomes minus 2. Second quadrant. Nah? It is the second quadrant. So abscissa will become negative. Direction is negative. But magnitude wise it is 2 and 2. Distance is 2. It's on either side of the y-axis, distance is 2. Why I put minus 2 in coordinate geometry? The negative is to the left. If the x is negative, it is to the left of origin. And if x is positive, right of origin. If y is positive, it's above x-axis. Y is negative, is below axis. So that's only for direction. Okay, but magnitude wise, minus 2 and 2 is same. Right? So here you go. That's why. So what is happening? See, y is not changing. X will change. This height remains the same. The horizontal distance is changing. So therefore, write it down. So reflection stand. We write it this way. R for reflection. Write the points coordinate. You are doing graphical method, means you are using coordinate geometry. You are taking location of point, a pair of points to show the location of a point, the distance of that point from y-axis and x-axis respectively. So then you are saying image where it is, and that also you are giving with respect to coordinates. So when you go like this, reflection, yes, in x-axis. So here I will write it here, I love this. So here you write reflection of P, which is 2, 4 in x-axis, in y-axis. An equation of y-axis also called in x is 0. The equation of y-axis also x equals 0. Sometimes they say reflect a point 3 comma minus 1 in x equals 0. Instead of saying y-axis, I will say x equals 0. The equation of y-axis is x equals 0 because all the points which lie on y-axis will be of the form 0 comma y. That means the abscissa will be 0 and the ordinate will be any real number. So if I say where is 0 comma minus 3, it is here. On the y-axis here. Where is 0 comma 5, it is here. Right? It will be on y. And if y is 0, 2 comma 0, minus 5 comma 0, that will be on x-axis. So where I'll do it when I do coordinate geometry, but you should have no coordinate geometry when you are doing reflection graphically. Okay. So here you got this minus 2, 4, and this is a new point. Coordinates have changed, so name it as P dash. Reflect P, this is the language used. Reflect P 2 comma 4 in the y-axis or in the line in y-axis or in the line x equals 0, both the same, to P dash. So find P dash means coordinates of P dash, and that's 2 minus 4. So what is the formula number 1? Reflection of a point xy in y-axis. In y-axis, that is also x equals 0 is P dash, that is minus xy. So what happens generally? Teacher comes and just say we are doing reflection, okay, and then she gives the formula. But what is important is the understanding what are we doing. Okay? It is same reflection which you do in physics. So we have a point mirror and a line mirror. Now we are doing line mirror. Line mirror graphically. I will show you the construction also. Okay, this is formula. This is graphical. Teachers use graph paper to get. So graph paper say you will illustrate this. Formula, nothing is mentioned. Find P dash, Q dash, R dash, where P, Q, R is a triangle, and find its reflection in x-axis, and nothing is mentioned. Definitely you will use only the formula, which is faster. Why will you waste time in making? But show the image PQR triangle and its show the triangle PQR and its image P dash, Q dash, R dash when reflected in x-axis. Show graphically, then you have to do it graphically. Nothing mentioned. Shortest is formula, isn't it? So here, sometimes, most of the time they say graphically because the other questions will be asked in the thing will be find the area of the triangle formed, what is the name of the figure formed, find its perimeter, and so on and so forth. So then they ask graphically because it's easier to get the picture of the figure when you do graphically. So this is first in x-axis. So finish formula, we finish graphically, right, of the coordinates of a point, and what I have mirrorized, the axis. AX, ES means plural, both x-axis and y-axis or z-axis. You don't know about z-axis. So ES means plural, both axes. IS is one of them. So x-axis, AXIS, y-axis, AXIS. Reflect in both axes, AXES. Okay. So this is finished. So same thing if I say reflect. Now the same point I'll show you, same one. So to save time, reflects P in x-axis. So this is my mirror. To P double dash. So reflect, can I see? Yeah, reflect P, which is xy, or 2, 4. Let us see first 2, 4. 2, 4 in x-axis. In x-axis means x-axis is the mirror. Okay. X-axis is line, it is not a point, right? X-axis is a line. So here, and or its equation is y equals 0. If you have done coordinate geometry, equations of straight lines, you know equation of x-axis is y equals 0. Equation of y-axis is x equals 0 because all the x's are zeros on y-axis, all the y's are 0, that means the ordinates are 0 all the ordinates are 0 on x-axis, all the abscissas are 0 on the y-axis. Okay. Now what do we 2p double dash? I can't name same number na? Because I already named 2 and minus 2 and 4 as p dash. I cannot say again p dash. So same question. Reflect p to p dash in y-axis and to p double dash in x-axis. So we are learning both. So graphically I am showing and then formula. So even if you forget, suppose formula you forget, you just draw a rough sketch. You don't need a graph paper. In the paper, you just put 1, 2, 3, 4, 1, 2, 3, 4 and reflect and you get it. Because you know the rule. Drop a perpendicular and object distance equal to image distance. Wherever it comes, you see. That's all. Finished. Right? So there are things. So very few explain to you how to go about reflection in a line and reflection in a point. Now it will be very easy for you. Okay, children? So here, now let's see. Why this is the mirror line. So again, drop a perpendicular means straight line. You have graph lines, okay? And then just go about it. Naturally to go through 2 only. A straight line through 2. Okay? So then this distance is 4 units. 4 squares. P is at a distance of 4 units from the mirror line. That is x-axis. So go 4 units down from the mirror and 1, then 2, then 3, then 4. And where do I come? I come to 2 minus 4. What is not changing? See, the distance from the y-axis is not changing. That means the x-coordinate is not changing. The distance from y-axis remains same. So, there is a vertical displacement when you are doing an x-axis. And there is a horizontal displacement when you are doing an y-axis. So, that is when y-axis, the horizontal distance, the x changes, y doesn't change. And in x-axis, vertical displacement, so horizontal distance remains the same. So it is on this line, P double dash, or this is P double dash, is on a line parallel to y-axis. Its equation is x equals 2. Because all the x's on this P and P double dash will be same, x equals 2. A straight line passing through 3, 4, suppose a mirror line. The mirror line is passing through 3, 4 and 3 minus 6. So the equation of the mirror line is x equals 3. Okay? A mirror line is passing through minus 1 and 6 and 2 comma 6. So 6 is same. That means the mirror line is y equals 6. Of course, we will be doing in detail and depth when we do coordinate geometry equation of straight lines. Okay? You just put in my Gmail, you just put in what part you want. Okay, so exactly. So now you got it. Now what is so what you're getting? So P double dash you're getting 2 and minus 4. What is changing now? Same numbers, but one of them is changing in sign. That is the y ordinate sign is changing. So let us do the formula. Reflection of Pxy in the line x-axis. What is the equation of x-axis? I said y equals 0. Okay, is P double dash, which is x comma minus 1. So we have done graphically, showing in a graph how to get reflection of any given point when x-axis and y-axis are the mirror lines. Finished? Let us see point reflection. Now let us see, I will show you one in origin has a formula. Any other point also has a formula. But if you understood what I explained, what is the meaning of point reflection, right? So what do? So here, it's not necessarily always the point reflection I will give you as origin only, right? So let us do point reflection. That means same P in origin. So we'll do the same figure, okay? Now we are going to reflect. So I love this because you've written. Hope you have written this, right? So we have finished y-axis with the example, numerical example, as well as general formula where x and y is any point, represent any point. X represents the abscissa, y represents the ordinate, x is distance from y-axis, y is distance from x-axis. Okay? Abscissa, ordinate. A comes first, O comes later. So abscissa is x, ordinate is y. X comes first, y comes later. Alphabetical order if you remember. If you get confused between abscissa and ordinate. Okay? Now here, origin. So this is a point reflection because origin, children, origin is coordinate. So it is a point. Origin is a point. So reflect. Okay, reflect. So reflect word के लिए I am using the word R. 2, 4 in origin. In origin. So this is origin is not a line. Origin is just a point where the x-axis and the y-axis meet. So, and therefore sometimes they write 0, 0. So when I am giving you coordinates means it is a point. When I say what is 3 comma minus 4, it's a point. What is x equals 3 in coordinate geometry? It's a line. Don't say it's a value of x. That is the algebra. Okay? In straight lines, in coordinate geometry, what is the locus? What is the path of x equals 3? It's a straight line parallel to y-axis at a distance of 3 units. Okay. What is y equals minus 2? It's a straight line parallel to x-axis at a distance below the x-axis at a distance of 2 units from it. So again I told you I'll do all this when I do coordinate geometry. Even coordinate geometry you do like this, you don't have to by heart it. I will never allow you to by heart it. I'll explain reason why this happens, because as a child I also was very much interested in the whys, not by heart. Okay, so here origin. So what you'll do, I told you rule, take a scale, not freehand. Say I'll be making a crooked line when I do freehand. Okay, take a scale and then you just draw from here. See, it's crooked. So if you draw freehand, it will always be crooked. So take a scale and just extend this line, straight line. That is point reflection. I told you that is the rule of point reflection. So PO, whatever distance it is, you go same distance. You can keep a ruler or a compass. If compass is better, you put it here, turn your compass. Okay, and mark it. So this distance is equal to this distance, P dash. And you will see when you read the coordinates, okay, it will come like this, minus 4. So it will come here. So if you see object distance is equal to image distance and minus 4, minus 2 minus 4. So it will come somewhere here, sorry. It will come somewhere here, this point. So it will come here. Minus 2 minus 4. It will come at this point. If you exactly do it, okay. This is all crooked because I am doing freehand drawing, children, and I don't have, I'm not doing on a graph paper. So it looks very crooked. Okay. So here if you see, I'll show like this. This is 2, this is 4, right? And these two will be, children, congruent triangles. Even if it's our teacher, I say, bol rahi hai, she just saying, no, children, we can go for congruency also. So this distance is equal to this distance. Then, you know, vertically opposite angles. And these two are 90 because you have to drop a perpendicular, right? You have, for distance, you have to drop a perpendicular. So you make two right angle triangles. So therefore congruent triangle. So this distance has to be equal to this distance. They are congruent sides, okay, equal sides, and this has to be equal to this. So therefore this is 2, this will be 4. So many ways of doing, children. Therefore, but it is in the fourth quadrant, so it will be minus 2 minus 4. Minus 2 minus 4. So what's happening? Same magnitude, but opposite in sign. So if it's the point is 3 minus 5, reflection origin will become minus 3 5. If the point is minus 5 minus 1, reflection origin will become 5 1. If the point is minus 6 comma 7, reflection origin will become 6 minus 7. Both will change in sign. That is reflection in origin. Okay. So here this you'll see P, what let's call this as reflected to Q. So P reflected to Q in origin becomes minus 2 minus 4. So what is the formula? Reflection of any point xy in origin. Hope you are seeing the board. Yes, in origin 0 0. Okay, is Q, which is minus x minus 1. So, you know, in class I enter and I just come and say, okay, we are doing reflection, children, and x-axis is right by heart, and that's all. And then if you want to do by graph, so it will finish in no time. But it needs real explanation and you understanding. So that correlation of explanation, understanding, illustration makes maths a wonderful subject. It's a wonderful subject. Okay. So here, that is, you finish 3 things, formulas. So just going through, reflection of any point x comma y in x-axis is x comma minus 1. Reflection of any point a comma b, let us not only say x, y, suppose, a comma b, okay, in y-axis will always be minus a comma b. And reflection of any point x comma y in origin is minus x minus y. Let us take one example. Suppose, so we have done reflection of 5 comma 2 in x-axis, 5 minus 2. So reflection of a point A to A dash in y-axis of 6 minus 2 will be minus 6 minus 2. And reflection of minus 7 comma 0, reflection of minus 7 comma 0 in origin is not 7 minus 0. 0 is a non-negative integer. If I say negative integers, you'll only say go from minus 1, minus 2, minus 3. Positive integers 1, 2, 3, 4. 0 has no sign. You never write minus 0. Neither you write plus 0. Okay? So, because 0 is the point of measurement for integers, it is the starting point. So 0 has no sign. So I cannot write reflection in origin as minus 7 minus 0. So minus 7 0 in origin. Okay, will this is say A reflected will be A dash, which is 7 0. No minus 0 children. In case you write minus 0, you should not write. There's no minus 0, there's no plus 0. 0 is it has no sign. It's a non-negative integer. So therefore, you have, that is the answer. So I'm rubbing this out because I've done the formula. I've illustrated coordinates, reflection in x-axis, y-axis, and origin. But you are not always given find the image. I'll give you object and image and ask you, is reflected in L1, describe L1. Okay. For example, number 1. Okay, image of A, which is minus 3, 4, is reflected in the line L1, not mirror, some line. We don't know the line. Okay, to A dash, and it gives me 3, 4. So mirror I know, image I know, right? So describe L1. What is L1? So only both the magnitudes are same. You do many kinds of reflection, children. You all only start with x-axis, y-axis, origin, and line parallel to x-axis and line parallel to y-axis. But reflection can be in inclined lines also, right? So the concept is same. Inclined line concept is same, right? So minus 3, 4 and A dash 3, 4, right? So therefore, what is changing in sign? X is changing in sign. So L1 is y-axis. Because x is changing in sign, y remains the same. If case you have doubt, in case you have doubt, make a rough sketch in your plain paper. You don't need graph for everything. And you locate minus 3, minus 4, 2, 3, 4. So minus 3, minus 3, 4 is here, which is A, this point, and then 3, 4, 1, 2, 3, same 4. 3, 4 is here. Yes. So which is your mirror line? This one, obviously, because this distance is equal to this. So this is your mirror line. And what is the name of this line? Y-axis. There is solution to every problem in mathematics. There is a solution to every problem in life. So we should not run away from problems. Right? So you are seeing a hot news on today's news about Sushant Rajput. Okay, very good. Such a talent. He should not have run away from problems. He should have faced problems. So don't run away from maths. Right? Don't run away. So easy. Don't know? You have another alternative. Draw a diagram. You know the rule. That first, and here object image. Locate the points. So you know this distance equals this distance. This is the mirror line. So one more thing you write. One more thing I forgot to write. So therefore L1 is y-axis. So in quadrant L1 is y-axis, and what is the equation? In quadrant geometry they ask you what is the equation. So x equals 0. Okay. So that is one point. I forgot to tell you one thing that is very important. When you have line reflection and you have a point P and P dash, I told you perpendicular this and this. So write it down in your notes. The mirror line is always the perpendicular bisector of the line joining object and image. Again I repeat, the mirror line The mirror line will always, this will help, they'll ask you a coordinate geometry में one question, which is based on this concept. They'll ask you on locus one question, draw the locus or point equidistant from 3, 4 and 3, 6, right? You'll see all that. So mirror line, write down. So mirror line, L1 is the perpendicular bisector of PP dash, meaning line joining the object point and the image point. This distance, and it's perpendicular. You know perpendicular bisector? A line which is perpendicular to the line and also bisects the line. If you're perpendicular bisector, say B and A. So you know this distance. Line you don't know, this. You know PP dash distance. If this distance is 6, this will be 3 and 3. Right? If it's 7, it will be 3.5, 3.5. So perpendicular bisector of PP dash. This distance is equal to this distance. So this is your PP dash. Okay. So this mirror line will be perpendicular bisector. Remember with it. Write that note. Okay. So I will come back to it when this particular point is used. So every little bit I'm explaining, children, it's applied in some part of mathematics, and that becomes difficult because with this minute details, if you do not know, that is the reason you find the problem given is difficult to solve. Okay? So this is the rule for the reflection. So I told you, now object image is given, find the reflection. So we finished all that. So it's not necessarily. So another question which comes in ICSE, a point 5, 0, point 5, 0 it remains invariant when reflected in the line L1. A point 5, 0 is invariant when reflected in a line L. Describe the line. Write it into it. What is the meaning of invariant? That means the coordinates do not change. The image and the object's coordinates are same. This is also A dash is also 5, 0. So 5 is not changing and we don't write a minus 0. So if it's 5 and minus 5, it is changing, becomes variant. Then you say it's reflection in y-axis. X will change in sign, right? But no. So 5 is remaining same and 0 you don't write minus 0. That is the secret. That means it's reflection in x-axis. L is x-axis. Again I repeat, a point A 5, 0 is reflected in a line L. You can copy it down and say it slowly. It will take time for me to write. Okay? I'm not using the smart board, children. I'm using an ordinary board and an ordinary teacher. I just want that what I explain goes to you. What I explain. So here, so again I write a point A which is 5, 0 remains invariant, does not change. Variant changes, invariant does not change. That means the image coordinate is also same. So point A 5, 0 remains invariant when reflected in a line L. So describe the line L. Right? So the L is, now you know 5 is not changing in sign and 0 you don't put a negative sign. So this is reflection in x-axis. So this is x-axis. And equation I told you is y equals 0. So L is, the equation is y equals 0. So such kind. So 0, minus 6 is invariant when reflected in a line. Okay, L dash. What is L dash? Write its equation. So 0, minus 6 is invariant means the image is also, okay, is 0, minus 6. So minus 6 is not changing and 0 you cannot write with a negative sign. So 0, minus 6 remains as 0, minus 6. This is P dash. This is P in a line L dash. So what is L dash? It is minus, so X is changing. So Y is not changing in sign and 0 cannot be written as negative. So therefore Y, this is Y has to change in sign. So X axis and this is Y axis. This is the reflection in y-axis. X changes in sign because y is not changing, and y-x is not changing in sign here because it's 0. You don't write a negative sign. So I discussed all that can be given in reflection in a line. Okay. So you have done that. Now only one more thing left. What about parallel lines? Reflection in parallel lines. So sometimes I may give another, like I would like to send PDFs, but I'd like to give a different kinds of questions which can come in reflection. Okay. So now reflection in lines. These are mirror lines. Okay. These lines are mirror lines. Parallel to axis. Any axis, x-axis, or I use plural. So just write down, if you have x equals some number, write down, this is a straight line, write down children, straight line parallel to y-axis. And if you have y equals some constant, only one variable and a number, not x and y. Okay, not x and y both. X and y both are there in the equation means it's a slant line. Okay, x is 0 is y-axis, y is 0 is x-axis, and parallel line. So this I'll give you the diagram. Is a straight line. Parallel to, so if you can't see the board, parallel, I'm just using some symbols, parallel to x-axis. So one way, x equals 4 is a line parallel to, and positive 4 it is. So x is a straight, 4 is a straight line parallel to y-axis at a distance of 4 units to the right of y-axis. X equals -2. It is a straight line parallel to y-axis at a distance of 2 units from it to the left of y-axis. Left side is x is negative. So I'll show you all that. Okay. So therefore, first you should know, how do you know parallel lines? So only x and a number. So always not ready-made pudding is given, children. Always ready-made pudding will not be given. Meaning I'll give you 2x minus 6 is 0. So you have to take 2x equals 6. Therefore x equals 3. You have to bring it in this format. Now you will say, teacher did not tell what is 2x minus 6 line. Make x subject to formula. There is no y in it. So this is a parallel line. Okay. So you take the number there, divide. So x equals 3. Okay. So therefore you have written this. This is parallel lines. So these lines, when they become the mirror lines, how do you do graphically and how do you do formula? Graphically also by graphs. Object distance equal to image distance. Drop a perpendicular. That's all. Same rule. Graph is easier, especially for average students. I'll never use below average. I'll say children who do not study maths, who run away from maths. Okay? So, if you run away from problems, problems are not solved. If you hold the problems tight, okay, and let them not worry you, and you worry the problems, you will be happy and you will be successful. Right? So the problems will become scared of you and they'll run away. If you hold them tight, fight with them, okay, and live with them. So here you have this. Now let us see. So I showed you this. Similarly, if you have line 2y, if I gave you like 2y plus 1 is 0. So you make y subject to formula. Again, this is a line parallel to x-axis. Y x-axis. X parallel to. So don't think it's x parallel to x-axis, y is parallel to y-axis. No. It's reverse. X equals 3 is a straight line parallel to y-axis. Y equals something, is a number is equal parallel to x-axis. X comma y coordinate. X is distance from not x-axis, y-axis, and y is distance from x-axis. Okay, that way. So if you had written maths, I think you would have written that way. So I think that would have been easy. I don't know which mathematician wrote that. Isn't it, children? So here, let us see this now. Okay. Now, suppose I say 2x plus 8 is 0. So I'll make x subject to plot this line. Very easy to plot. You make a graph paper, you have your graph paper, you try it, ask your mummy, ask your papa to give some signs, or take out your book. If you understood, I'm sure you understood 80% of it. So the 20% why? Because you have to practice and see whether you can do or not. I am doing on the board and you are not doing, this not. So you also have to practice. Now this is x-axis and this is y-axis, 0. Now 1, 2, 3, 4, keep marking. 1, 2, 3, 4, and you mark, I'm not marking. You know what it is, each square, each is 1 unit. So 1, 2, 3, 4, and minus 1, minus 2, and all, and minus 1, minus 2, and 1, 2. X equals minus 4. So x is minus 4 is here. Minus 1, minus 2, minus 3, minus 4. This line. This is x equals minus 4. This is equal to x equals minus 4. So this minus 4 is minus 5. So let us go. This is, can you see the board? Yes, minus 6, minus 7. So now you got this, right? So this becomes a mirror line. It's looking very crooked, children. I'm very sorry. It should be straight. So straight line, children, perpendicular and parallel, okay? I made it very crooked, I'm sorry. Okay? So x equals straight line, perpendicular, perpendicular. I'm sideways now, so it tends to be crooked. So here, this is x equals 4. So let us do, so you understood, x equals 2 here, x equals 5 here. So that means, what is the meaning? Why it is called x equals 2? All the points on this line will always have excess to, y will be any number. So 2 comma 2 is here, 2 comma 4 is here, 2 comma 5 is here, 2 comma minus 1 is here, 2 comma minus 4 is here. So always the excess 2. Okay, you said Rita Ghosh, Meeta Ghosh, Ashok Ghosh, okay, Anil Ghosh. You said the Ghosh family, right? So like that. So here it is 2, x is 2. So all points on this line, the abscissa will be 2. So that is why it is, we draw a straight line. Okay, fine. So x equals minus 4 is a straight line parallel to y-axis and to the left of y-axis. Right? I gave you the notes. Now suppose I say minus 7 and minus 2, you have to reflect this point. Reflect. Now we'll do graphically. Reflect minus 7, minus 2. Reflect minus 7, minus 2. Let us call this name. R is for reflection, put colon. A, 2. Okay, x equals minus 4. I can give you x plus 4 is 0. I can give you 2x. What I gave you? I gave you 2x plus 8. Make x subject to formula. Let's see what number you get. That is my k or a which I wrote in the formula. K and a are some numbers. Make it subject to formula. You should not have any y. Not two variables. One variable linear graph. Okay, when teacher has taught you plot x plus y equals 5, 2x minus x equals 6 or x equals 3 and y equals, that time only you should have done how to plot lines. Many must have done. Okay. So now you have to find the image. What is the rule, children, for image? Drop a perpendicular on the mirror line so it is straight. So this is straight. So therefore, where is minus 7? 2 here. 2 is here. Minus 7 is here. So you know how to locate coordinates. This point is minus 7, 2. This point is minus 7, 2. So we join. So see, the mirror distance how much? 1 step, 2 step, 3 steps. So this object, minus 7, can you see, children? This is minus 7, 2. This is my point here. Minus 7, 2 is here. Okay? It is here. So it is 3 units from the mirror. This is the mirror, arrow 1. X equals minus 4 is my mirror. It is 4 units. See here on the graph. Here, from here you can see. Here is the point. Not minus. This is minus 7. This was minus 6. This was minus 5. This was minus 4. So minus 7, 2 units. So, but it is not minus 7 units from here. 7 units is from y-axis. So from here it is C. See how many steps? 1, 2, 3. So go 3 steps to back side. 1, 2, 3. We stop here. Here is the image. So what is the point? A. So here is your A dash. So that has come where? So 3 units here, 3 units here. You went magnitude wise. Now you have to write coordinates of this point. Position. Okay, distance is 3 units from this line. So coordinate will not be 3 and minus 2 or minus 3 and minus 2. No children. The coordinates are always from y-axis. So this point I got. So it is already at a height of 2 only. 2 has not changed. But where is it? It is at minus 1. See, at minus 1. So it's minus 1, 2. It is minus 1, 2. So A dash will be minus 1. Sorry, this is 7, 2 children, not 7 minus 2. 7, 2. So 7, 2. I took 7, 2. 7 minus 2 I should have taken here. Okay. So 7 minus 2, the answer would have been 7 minus 2, and the answer would have been minus 1 minus 2. Okay. So anyway, sorry I made that mistake. So that is the rule. Again I repeat, this is the mirror line parallel to y-axis. Then this is, locate the point and see how far it is from there. See the coordinates, how many steps, 1 centimeter, 2 centimeter, 3 centimeter. 3 steps you go, 3 steps you go by object distance, image distance. 1 step, 2 step, 3 steps, which is here. So this is 3, this is 3. According to my figure, it is not looking same, but should be same. And what is the coordinate? Minus 1. So you can see the distance from minus 1, yes, 6 and 3 are correct. Is it clear? Distance from minus 7, 2 to minus 1 to 6 units. So half of that. Okay. So that is how you find the. Let us do the other one, parallel to y-axis. Parallel, so that's all. Now we'll do formula both together. So parallel to y-axis. Okay. So I'll rub this. Now you do nicely in a graph paper. My lines are not coming straight. Okay. Okay. So this is minus 1, minus 2, minus 3, minus 4, minus 1. So this is 1, 2, 3, 4. Now suppose reflect a point P which is 5, minus 1 in y equals minus 2. Okay, y equals minus 2. Or let's say y equals 2. So 2, reflect it to P dash and find its coordinates. Again children, here you are finding image. They can give you object and, they can give you the point object and the image, and they ask you the equation of mirror line. So you just join them and see what is the distance between them. Halfway you make a line parallel, and then you see the coordinates. The line is passing through which point? That is the equation. It is passing through x equals 3. Its equation is x equals 3. It is passing through y equals minus 2. Its equation is y equals minus 2. I will show you that. So let us see this one. Now you are doing what? We have finished the first one in parallel to y-axis. Now we are doing parallel to x and y equals some number. Children is parallel to y. In the line, reflect to P dash, you will find the coordinates. So you already know children, y equals 2, x won't change in sign. In x equals 2, in x equals we did the previous one, the y did not change in sign. The x will change in number, y won't change. In y equals a number parallel to x-axis, this is y. So the y will change, but x will remain 5. So that's how we do formula also. So answer will be 5, some different number, not plus 1 or something. It will be totally a different number. But x will be 5 only. In the previous one we saw 2 did not change. Reflection x equals minus 4 we did. The 2 remained as 2, isn't it? So here let us do y equals 2. This is y. Y is here on the vertical line. Y equals minus 5 is here. This is minus 5. I told you parallel to x. Y equals 2 is here, and I told it's a line parallel. So take a scale and draw a parallel line, and you have a graph paper, but still you have to use a scale. I don't have graph paper, so मुझे माफ कर दो. ठीक है? So this is the line. Y equals 2. I can give you y minus 2 is 0. You try to bring the 2 that side. You have to make y subject to formula. Okay? So you got that. Now 5 minus 1. Where is 5 minus 1? So minus 1 is here and 5 units. So 5 minus 1 is here. So 5 units horizontal, 1 unit downwards. So this point is P, which is 5 minus 1. You know how to locate, children. 5 and 1 down. 5 horizontally right and 1 down below x-axis. So that is 5, 1. I located it. Okay. So you see very carefully. This is the point, this is the mirror. So you go, this is one step already, 1 here. So 1 step, 2 step, 3 step. Coincidentally, this also comes as 3 steps. Here, 1 steps here, 1 step, 2 step, 3 step. Go 3 steps the opposite side. 1 step, 2 step, 3 step. So it comes here. Here it comes. So image P dash will come here. See? Here, 3 steps, I went 3 steps. This won't change. This is not changing. Vertically it's changing. If line is vertical, the vertical coordinates will change. If the line going horizontal, the horizontal coordinates will change. So you see 3 steps from the mirror line, 3 steps. Now see the coordinate. This is the position. Now read its coordinates from the x-axis and y-axis. This will remain 5, I told you. And what is the y from x from x-axis, not this line. Close this line. So what is the position of y p dash from x-axis? This is 2 units and this is 3 units. So it is 5. See, you can see this. What is this one? See, 1, 2, 3, 4, 5. So this comes as 5. You can read also. This is x-axis. This is 3 already. Object image distance. And this is 2 because y equals 2. So 2 plus 3. Okay, is 5. Therefore, you have from x-axis. Coordinates can you have to measure from x-axis and y-axis, not from the mirror. For distance, object distance, image distance from the mirror, not from x-axis. Don't get confused. So you got image of P, which is 5 minus 1, in the line y equals 2 is 5 and 5. See, x did not change. X did not change. 5 minus 1 in the line y equals 2 is P dash 5, 5. Distance is 3, children, from the mirror line. But position of a point is always with respect to x-axis and y-axis. So from y-axis remains the same, 5 units. From x-axis it has shifted. Here it is. So how much distance is here? From x-axis 2 here and 3 here, 5. So this is from coordinate geometry. So let us write the formula for this also. So we did graphically how to reflect a point given in coordinate form in the lines which are not x-axis, y-axis. It's in mirror lines which are parallel to either x-axis or y-axis. How do you know a line is parallel to x-axis? It will be y equals a number. You have to make y subject to formula, the number. If it's, the number can be positive or negative. Y equals 3, it is here. If y equals minus 1, it is here. X equals 5, it is here. If x equals minus 2, it is here. That's all. Okay. So after drawing this, I'll rub this. Now the formula. So write down the formulas for this. So reflection in lines parallel to x-axis. So write down P of x comma y is P dash. We are doing chapter reflection. R stands for reflection. Okay. R stands for reflection. In the line x equals, after you made x subject to formula, you got a number. So k is a number. It's a constant. You can say constant. After you make y subject to formula. X will change, so I'll call it a new name. Y will not change. Y will be same. So the ordinate of object point and image point will be same. So if it's x equals, all x's will change. And what is the relation between this, and this? Right now. So x dash is twice k minus the x. X dash is this. That means the ordinate of the image, okay, is equal to twice this number after you make x subject to formula. If it's negative, you take negative sign. If it's positive, you take positive sign, minus this. Just now we did, children, what was the point we did? We did 5 comma, what was this? In x-axis, x was minus 7 2 we did, right? We did what? P minus 7 2 in the line x equals minus 4. So x will change, y will remain 2. We got 2 as the answer there. So what is x dash? I have to find this. So x dash is twice minus 4. K is minus 4. And minus. X is minus 7. So don't write minus 7. It's minus of minus 7. So minus 8 plus 7. So we got minus 1. Did we get minus 1 too? See mine, if you go back, we did get minus 1 too. So therefore, P dash is therefore minus 1 2. If you go to my example, if you written down or you go back to my video, okay, you will get, I did in x equals minus 4. The point object was minus 7 2 and the answer was minus 1 2. See, we got minus 1. So if it's not given, solve graphically, just find the image, you can use the formula, right? What happens? The next formula. So I will keep this example. Let's see. Okay. So it finished, right? Now reflection of a point in y. Same thing. So we have done the formula. So in y are now parallel to x-axis. So suppose y equals k. Not same number, I'm just putting. Okay, let us put A. So A is a constant, a number. So that will be x won't change, y will change. Y hai, the y's will change. So therefore, that means horizontal distance won't change. Right? So you will write y dash, same thing, twice A. There it was twice k. If it's k, you put twice k. Minus y. No x. Y will have only y's, x's will have only x's. Okay? Right, children? So, what was that other one which I took? I took y equals 2, right? And the point was 5 minus 1, whatever it was. So, 5 minus 1, point P, say A reflected in y equals 2, becomes P dash. This arrow, what I am writing is the equation of the mirror line. This line is parallel to x-axis and P dash, and that will give me x won't change, so 5, and y will change. So I give a new name, y dash. Put a y dash or y1, put a y dash or y1, whatever you want. Okay. Now what is the relation? I already, so y dash equals, right? Y dash equals twice 2. Not positive sign, positive, negative, negative. Minus the y of the object, that is minus of minus 1. Not minus 1, minus of minus 1. If this is y equals minus 2, you put minus 2 here with this sign. So y dash is 4 plus 1. So that becomes 5, 5. Remember, I remember the point, I remember the answer. Do you remember? I remember the point, I remember the answer. See, 5, 5. We got 5, 5. The y dash I got as 5. So the image, the coordinates of the image is 5, 5. Right? So this is, I did graphically. If you have doubts, suppose you forgot the formula, no problem. You don't have graph paper, it's not given to graphically. You can straight away in your plain paper make x-axis, y-axis, just put coordinates, right? And draw the line, you know y equals something is parallel to x-axis, x equals then object distance, image distance, perpendicular bisector. So wherever the object is here, this go, you measure this, go this way, and now read the coordinate. This is the coordinate. This is the coordinate. This and this are coordinates of this point. Distance wise I shifted. So x won't change, y will change, because this is y equals, this x equals something. X equals 2 may, so the x will, this is x equals 2. So you are doing, the object is here, the object is here, image is here. So you will see the y is not changing, x will change. So here, now suppose I give you 3 comma minus 2 is reflected in a line and the image is 3 comma 7. So not graphically. Suppose you forgot the formula, do graphically. Locate these 2 points. Okay, and you know x equals 3. That means this will be this a dash will be parallel to y axis. 3 3. Equation of a dash is 3 3. Sorry, x equals 3. So it will be parallel to y axis. So your object will be here, image will be here. So here you can see y is changing in sign, x is not changing. Find the mirror line. Find the reflected in line L1 of L. Find mirror L. Find the mirror line L. So here you have to find. First we did find image. I'll give image, find object. Same method. Actually image is object only. If I see my image, you can take that as object only, and I am the image. Because we are same distance from either side. So if I give you image, find object, same rule, no problem. It will be image here, it's only name will change, a dash. You come this side and name it, that's all. Object distance, image distance, and you drop a perpendicular on the mirror line. Okay, so here, what you do, x is not changing, y is changing. So therefore it is, the line L will be y equals k. Y equals k. So take as y equals k. How do you know? Because y is changing. Now put the formula. Y dash, this is my x dash, this is my y dash, this is my x and y. So y, not x dash, this is x only, because x is same. So y dash equals twice k minus y. Formula, y dash is 7. I have to find k. So I know y dash and y. This is image, this is object. And minus of minus 2. Don't write minus 2. Minus 2 it is. So 7 equals 2k plus 2. So 5 equals 2k. So k equals 5 by 2. So this means 2k is 5, k is 5 by 2. Therefore, the equation of the mirror line is y equals 5 by 2. If you want to put a more beautiful way, 2y equals 5. Or even you can say 2y minus 5 is 0. You can also say 2y minus 5 is also 0. Understood? So another one where you have, and then I'll end the class. Okay? So you put messages in Gmail if you liked it or you want anything more, because you have. So we have done reflection and X point reflection. So in another class I'll do figure reflection. So that I'll do in line symmetry also. I'll do how do you do reflection. So it will be too long a class for today. So we'll stop with point reflection and line reflections of points. Okay. So here you have, now when you have figures in x-axis, y-axis, how do you do? And name the figure, find the area. So we'll look to that. Okay. That will be another session, say part 1 and part 2. So remember, if I say in part 2, children refer to my video which I did before. Please check on my YouTube for the videos. Because if I've done one, I'll say this is the second chapter in reflection. Because reflection is not ended. Then we'll do reflection of triangles, squares, trapeziums. Or you reflect a line in another line. You get and join the points, the two lines. You get a trapezium or a square, rectangle. Then ask you area, perimeter, all that. So that will be a second part to reflection which I'll be doing in my video. I'll call that as video 2. If I say video 2, you must see my video 1. Children, I gave for 11th standard, I gave 2 videos on trigonometry on one chapter. Okay, so if it's video 2, you must see video 1 because there's a continuity there. I'll be mentioning this is I'll continue in my next video. So I will end up and say I'll continue reflection in the next video. So when you see it's video 2, you know there's a video 1. So there's no connectivity if you see my video 1, 2 and don't see my video 1. Okay? So because this is the introduction of the chapter, so that's very important. Right? So now same thing, suppose I say 5 comma minus 2, minus 5 comma minus 2, A reflected in a line L and becomes A dash, and that becomes 10 comma minus 2. So find the mirror line. What is not changing now? Y is not changing. Y not changing. X is changing. Therefore, this equation will be x equals k. Whichever is changing, the line you take x equals k. So it's a line parallel to y-axis. It's a line parallel to y-axis. Right? So x changing, take x. Y changing, x won't change. Right? So without graph you can do. Or if you have doubt, you can do graph. You can plot this. So this will be a line parallel. Y equals -2, y equals -2. So it will be a line parallel to y equals -2. Parallel to x-axis. So locate this point. 5 -2 will be here. So -5 -2. It will be on the line. Okay. Sorry. This is mirror. This is the object image line. Sorry, this is P dash. So it will be perpendicular bisector of this. So you have P and P dash. So you have to draw perpendicular bisector. And this is the mirror line. Okay, that is graph me, you have to do that way. So let us see this. So this will be x equals k. What is the formula now? X dash. This is my x dash. This is my y. This is my x and this is my y. Y is same, so I am putting y. X dash is twice k minus x. X dash is 10 twice k. K I have to find out minus. Okay, let's take 5. Okay. Let's take 5. Every time we take 5, so minus 5. Okay, 5. So it becomes 15 equals 2k. So k equals 7.5 or 15 by 2. Don't put misfraction. Therefore, mirror line. The mirror line equation L is, what is it? X equals value of k. X equals, put here 15 by 2. So x equals 15 by 2. That is 2x equals 15. That is the mirror line. Okay. So we end up here, children. So it's quite, we have taken a little bit more than 1 hour, 1 hour 15 minutes. So I think that's enough. You are tired, I am tired. So thank you so much. Okay. Just give your subscribe, and just if you have any problem, mail me if any need any topic. But this is video 1 on reflection, so I'll continue with a video 2. Okay. Thank you, children. God bless you.